everyone, thank you for joining us for today's webinar, Caching In for SharePoint Performance. If this is your first time with us, SusQtech's 30 on Thursday webinar series is a bi-weekly series that is designed to keep you updated on the hottest topics, trends, and products for Microsoft SharePoint. Our next webinar will take place August 23rd, 1:30 to 2 o'clock p.m. Eastern Time. The topic will be Governance, Automation, and SharePoint with AvePoint. If you're interested in registering for this webinar, please visit our website at susqtech.com/webinars. If you have any questions or topic suggestions, please contact us at webinars@susqtech.com. We love to hear your feedback. Today's session is Caching In for SharePoint Performance. Our presenter is Sean McDonough with Idera, and I am Julia Oates, the Marketing Coordinator here at SusQtech, and I will be moderating today's presentation. Today's session will be recorded, and the recording will be up to view early next week at our website, susqtech.com/archived webinars. If you have any questions throughout the presentation, please insert them in the question window on the right side of your screen. We will get to them at the end after Sean's presentation. So, let's get started. Sean, I'm going to give you presenter rights.
Okay. All right, let's see here. There we go. You see that okay?
Yep.
All right, excellent. Thanks, Julia. My name is Sean McDonough. I'm the Chief SharePoint Evangelist for Idera. We make admin tools for SharePoint and SQL Server. I encourage you to check us out if you're in that market. This session is called Caching In for SharePoint Performance, and we're going to be going over a few things today. We're going to do a general run-through of caching concepts, just to establish a baseline understanding of what caching is and how it applies to SharePoint. Then we're going to take a look at each of SharePoint's platform caching options and then identify how you can leverage and control those in your environment. So let's start by saying, what is caching, or asking the question, what is caching? And anytime I'm trying to find a definition for something, the first place I turn is my trusty dictionary. And this is my Webster's Dictionary, and I decided to look up caching. And on the page there between cable and cadaver, I have a section highlighted. That is cache. And if we look up the dictionary definition, the first definition is a place in which stores of food, supplies, etc. are hidden, as by explorers or trappers. All right, admittedly, this is the dictionary I took to college with me, and that was over 20 years ago. Clearly, we need a more up-to-date definition. So here's what we're going to use for today. A cache is a temporary storage area where data that is either computationally expensive or slow to fetch can be placed for faster access. And that faster access is usually facilitated in one of two ways. If we consider a hard drive, standard spinning platter hard drive, the first mechanism or approach to caching that's implemented with most systems is to take data that's on that system or on that drive and put it on a faster medium. In this case, taking the data off the platters and putting them into memory. Since memory is accessed more quickly, we get better performance. That's one form of caching. The other form of caching that doesn't come to mind maybe as readily for many folks is to take data and put it closer to the point of usage. Now, for anyone sitting in front of a computer, that may not make much sense. You have most of your data right in front of you. But consider the case where you might have a server that's halfway around the world. There is latency and bandwidth restrictions that come into play when accessing that data. And so by taking that data perhaps from halfway around the world and moving it closer to us using something like edge caching, data is accessed more quickly, and that's another form of caching. But the ultimate goal of caching, all in all, is better performing, more scalable sites, and ultimately a better user experience. That's why we're doing this, to try and speed things up to keep users happy. So what does SharePoint have? Well, a number of confusingly named options, but they're each distinct in their own right in what they do. We have object caching, blob caching, page output caching, And with SharePoint 2010, we also have the Office Web Applications cache. Now, these are the options you have available to you as an IT pro or an administrator. There are plenty of other ways to do caching and to do that within SharePoint, but these are the knobs and dials that we most readily have available to us. Now, it's also worth pointing out at this point that everything I'm talking about is applicable to both SharePoint Server 2010 and MOS 2007, unless I indicate otherwise. So a little short story to go into this. I had a client several years back that was a Fortune 25 that was rebuilding out their internet presence on top of SharePoint 2007 just as the platform was launching. And I was tasked with putting together the platform, getting it up and running, getting it tuned. I knew that caching was going to be a big part of their success or their failure if I didn't implement it properly, just given the amount of traffic we envisioned coming into the environment. So as I got started with SharePoint and trying to implement this, I'll be honest, I knew that caching was going to be in play, but I didn't know where the on button was. Quite honestly, I knew that SharePoint had quite a few different mechanisms, but where was the on button? Is there even an on button? So I decided to start having a look and figure this out, because it was still relatively new to me at the time. This is a shot from Site Collection Administration, site settings page. If we dive in, we see that there's a Site Collection Features link. Many of you administrators are familiar with this. And when you click on that link, it takes you to all of the features that are deployed, active or inactive, to the site collection in question. Now, when we're trying to enable caching or work with caching in SharePoint, we're interested primarily in one feature, and that is the SharePoint Server Publishing Infrastructure. Or if you're still on 2007, this is the Office SharePoint Server Publishing Infrastructure. For any publishing site, like a collaboration portal or a publishing portal, this is active by default. If you're on a Teams site or a WSS site, it will not be active. Now, it's worth pointing out, the astute among you are probably going, now wait a minute, the publishing infrastructure, that's a premium feature, and you are correct. SharePoint caching relies on features that are found in SharePoint Server 2010 and MOS 2007. So if you're using Windows SharePoint Services v3 or SharePoint Foundation, you do not have these capabilities available to you. They are a value add with the paid server platform. So with that feature being enabled, you might be wondering, how does it actually work? How does it wire up? What's the plumbing look like? I'm very much a detail guy. I like to know what's going on under the hood. So if we dig in to the web config for any given SharePoint web application, this is a section of it right here, we can dive in, and you'll notice I've got circled the publishing HTTP module. That is one of the HTTP modules that's wired into the ASP.NET page processing pipeline, and that is the gateway to all of SharePoint's caching capabilities in terms of the ones that I shared with you. Everything goes through the publishing HTTP module in some way, shape, or form. Now, this is always wired in. If you go out to any web config for a web application, one of the zones in your environment, you'll notice that this is wired in whether you're using caching or not. So the plumbing is active, and the fact that it's always wired in means that certain types of caching, or specifically blob caching, does work fine with non-publishing site collections. You don't need to activate the SharePoint Server Publishing Infrastructure to use blob caching. You still need SharePoint Server 2010 or MOS 2007, but without turning on the publishing infrastructure, you can use blob caching and not have to worry that it's not hooked up. So this is a page that I put together, a mock-up that I put together in Balsamiq, just to demonstrate a SharePoint page. And what I'm going to do is come back to this page several times as we work through the different mechanisms that are available, so you can see what on the page would be impacted. For instance, what would be impacted versus an object caching versus blob caching. So the first caching option we have available to us is object caching. And what is object caching? Well, it is a form of caching that speeds access to frequently referenced structural, property, and result data. How's that for a non-definition? That's about as bland and generic as it gets. Object caching makes things go faster. So what does it make go faster? Well, Let's look at the page that I've put together. You'll notice I have a number of different areas circled in orange. Object caching affects quite a bit in the environment, starting with things like navigational data. If you're using the portal site nav provider that is used typically with MOS publishing sites and SharePoint 2010 publishing sites, then navigational data such as the sitemap are going into the object cache so that every time navigational information needs to be rendered on the page, there's not a round trip to the content database. The same goes for the quick launch, because the quick launch again uses the same sitemap to determine what gets shown and where you are in the navigational hierarchy. Frequently accessed properties, like the title of a SharePoint site. Any time that this title would be needed, SharePoint might have to round trip to the content database. But by caching that information, and it doesn't change very often, we can avoid a trip to the content database just to get the data we need. Where we really start to see some benefit is when we start to dive into things like cross-site queries in the content query web part. The results of a cross-list, cross-site query can go into the object cache. And since these are particularly expensive operations in terms of hitting the database, being able to cache the content query web part content and other cross-site data queries allows us to get a big benefit just by storing results in memory. And then finally, if you're using publishing sites and publishing page layouts, those can be cached. So there are quite a few different things that get touched by object caching. Now, object caching is implemented in memory. It's data that gets stored in your memory of web front ends typically. This is turned on by default for you, so you're getting some benefit from it, probably whether you realize it or not in your publishing sites. And there's a default allocation of 100 megabytes per site collection. Now, it's not a 100 megabyte chunk that's immediately blocked off. It can grow to be up to 100 megabytes per site collection, and that is tunable. We do get a new trick with SharePoint 2010, though. Since the tuning can be done within the site collection, this sometimes does not rest too well with administrators who want to more closely monitor and control the memory in their environment, because an errant administrator working to increase that allocation, for instance, could tip the balance inappropriately on the server, consume too much memory, and cause operational problems. So SharePoint 2010, if we dive into the web config, you'll notice this object cache element, which gives administrators a maximum size override that will be used in place of what goes into the site collection. So this is the administrative override for settings that site collection admins who may not be farm administrators could change. So using object caching, we've got a couple of primary knobs and dials that we can play with, and we come back to site settings. We go into the site collection object cache link, and that's where everything appears that we can play with. This is the page you typically see. It looks much the same in SharePoint 2007 as SharePoint 2010. There is the object cache size, and this is the primary control in the absence of an override, and it is set to 100 megabytes by default. Now you might be wondering, hey, I can tune that up or down, right? And that is true, but I want to share a painful story with you first. You see, I talk about caching. It's partially cathartic, partial penance for me, because I've done some horrible things in a previous life and other environments. And in one particular environment, before I understood how the object cache worked, I dialed that allocation down. I mean, way down. I'm not going to tell you how low I actually took it. But shortly after I did that, and had forgotten to change, of course, we started to experience all sorts of problems in the environment. The page processing pipeline was tipping over. The server refused to serve pages. Eventually, after months of troubleshooting, we traced it back to too low an allocation in the object cache. The memory was being very constrained, getting fragmented. Compactions were taking place. It was a very ugly story. So the takeaway from this, don't dial that object cache allocation down unless you really understand what you're doing. Now, there are a couple ways to keep an eye on what you are actually doing from a memory perspective. TechNet will tell you to watch the publishing cache hit ratio and total object discards performance counters. Those are good starting points, but the problem is, particularly with the publishing cache hit ratio counter, it only resets when you reboot the server. So if you've had plenty of uptime and you make a change, you may not notice drastic changes, for instance, in your new hit ratio, because previously you had a fantastic hit ratio, and that's diluting the effect. What you should be watching is the total number of cache compactions, and this is measured per hour. And if you're seeing more than 5 to 6 cache compactions per hour, ideally you see none, but if you're seeing 5 to 6, you're in a memory-constrained position. You really need to get the object cache more memory. Now another setting we have the ability to reset the object cache, both on the server itself and force a flush across the whole farm. If you're a developer and you're working with the object cache, this may be something of interest to you since it allows you to test cache code, or rather remove caching as an effect on your code. Just flush the cache and bring it up clean. Cross-list query cache changes. Trust me, you don't want to try and say that 5 times fast. In essence, what it is should I use caching for cross-list, cross-site queries or not? For SharePoint 2010, this is turned on and it's set to 60 seconds. For SharePoint 2007, it's actually turned off. So they turned it on with 2010, and this is what allows you to cache the results of cross-list, cross-site queries like the content query web part. And then finally, there's a cross-list query results multiplier. And this is set to 3 by default. What it means is if the object caching system needs 10 results, it'll fetch 30 from the database. The reason being security trimming. Object cache fetches in a privileged account context, and results are served back to user in a security trim fashion. So there's always a chance that the object cache may not pull back enough results with just 10, if you need 10, to service a current user. So this is a form of insurance. It brings back additional results so you don't need to round trip to the database if you come up short. Guidance for this: in purely anonymous scenarios, it's good to send your cache durations up and cross-list multipliers down. Reason being, most users are functionally equivalent. They're all anonymous, and it's typically a read-only environment. So you can cache things longer, and since users are the same, you can send the multiplier down because security trimming shouldn't be a factor. In authenticated scenarios, the advice is strictly the opposite, again, because it's read-write, and you've got a different situation where data is probably turning over and there might be security trimming. And that multiplier really needs to go up if you're using per site or per item security to avoid another round trip to the content database to cover for the cache not having enough in terms of results. So that's object caching. Now, object caching buys us some benefits at a couple different places in our farm, and this is my sample farm for illustration purposes. If we dive down to the content database level, we're reducing the number of queries to SQL Server. So this is going to reduce network I/O and SQL Server load because we're caching items where we need them on the front ends. And on the front ends themselves, it's cheaper to fetch things directly out of memory and serve them back than, for instance, to try and compile and run cross-list queries, cross-site queries. So we do save some time in processing on our WFEs. So that's object caching. Next up, we have blob caching. I love the name alone, blob caching. And no, it's not that kind of blob. Blob in this case is a binary large object. These are documents and attachments that you typically upload to SharePoint, Word docs, images, things like that. This form of caching is also known as disk-based caching, and that gives you probably some insight into how it operates. So let's take a look at our mock-up. I have a bunch of things highlighted in pink here, and those are the things that would be cached through the blob caching mechanism. So you'll see that anything that's an image is highlighted in pink, that big banner across the center, as well as this little video clip here, because blob caching can be extended to cover any static file type. Flash, PDF are pretty common additions. Multimedia files are pretty common. It's all about big files that typically don't change too often. That's what we get with blob caching. Now, blob caching is backed by disk, so what you're doing is you're taking blob assets from your databases, your content databases, and the first time they're used, they get placed into the file system of the WFE, or the web front end, and served from there. This avoids the constant round tripping of the content database to pull those assets back. Blob caching is turned off by default, but it can be turned on easily enough. And there's a default allocation of 10 gigabytes per IIS site or web application zone. This is partitioned on a web app zone basis because we control it through web config settings. And if we look at a web config and we dive into it, this is how we control blob caching. There's a blob cache element with a number of different attributes, a location, a path, things like that. We have a number of common attributes available to us. There are more than just the 5 that I show here, but these are the most common ones. Whether or not it's enabled, it's false by default, true if it's turned on. The location is the location in the file system where cache items are stored. By default, it's set to somewhere on your C drive. Most admins will want to move that to a data drive because these can grow to be substantial, and most people don't stick transient data where they can help it on their system drives. The path is what you use to specify what gets cached and what doesn't get cached. By default, it's set to a number of different multimedia file types, as well as JavaScript, CSS, things like that. What it actually is, it looks like a bunch of file extensions, and it is, but it's truly a regular expression that if you know regular expressions and how to create them, you can create some very interesting matching expressions to dictate what goes into the cache and what doesn't. The size, of course, this is how much space in terms of gigabytes that the blob cache can consume for that zone on disk. And finally, there's a max age parameter, which you didn't see earlier, but this is not actually specified in the blob cache element, but there is a max age in effect. And we need to talk about that a little bit more. And I'll do that in just a second. But one warning I want to give, because I've seen this happen a number of times, do not simply delete files out of the blob cache on your web front ends. You might think that it's like flushing and refilling, but in reality, when you delete it out, you are deleting the file but failing to update the catalog of files in the blob cache, and that catalog resides in a separate file. So you delete the item out, the catalog still thinks it's there, and you end up passing down a bunch of broken links and 404s to clients who are requesting assets that you deleted out of the blob cache. Now, I've got a bunch of links and references at the end of this presentation where I've written some articles on how to do this. I've even put together tools out on CodePlex for properly flushing the blob cache across your farms. So I do have resources to address this, but don't just delete the files. Now, I mentioned the max age attribute, and it's really important to understand how this operates because it has a tremendous effect on the end user experience. When you use the max age attribute, whether you realize it or not, what you are doing is instructing a client browser to store assets that are in the blob cache on the client side once they've been served down. This happens a certain period of time. If you don't specify a period of time explicitly in the web config through the blob cache element, it'll be 24 hours. So when you turn on blob caching, you have an implicit max age of 24 hours. Now, if I go out and flush my browser cache and take a look at the number of requests I end up making to pull back a page, I pick the page I know, and serving up that one page was 115 HTTP requests because I was pulling back not only the page, but all of the blob assets such as CSS, JPEGs, GIFs, all these other files that go into actually rendering the page or producing the page that I want to see. Now, when I closed out my browser and came back in, anything that came from the blob cache was, cached on my client side. I went back in. I only needed 4 requests to load the page. Out of that 115, 111 of them were served directly from my client without ever calling the web server. So as you might imagine, this can be tremendous benefit, particularly in internet or high-load scenarios where you're trying to reduce the number of requests into your front ends. Now the problem is, of course, this can work both for and against you. If you're turning over blob cache items, like if you're changing images frequently on your site, until that item expires out of the blob cache, a client will not re-request it. So they're stuck with the old image until they either flush their browser cache or it expires. So if you don't want this persistent client-side caching behavior when you enable the blob cache, be sure you explicitly set a max age value of 0. If you don't, you get 24 hours. A max age of 0 means it'll still be cached on the client side, but every time the asset is needed, the client browser will ping the server to see if there's a new update. It's not a perfect scenario, but it at least guarantees that you're not going to be serving stale assets from the client side. So if we look at our farm again and we go in and see where blob caching helps us, first and foremost, it's a big benefit to what happens between our web front ends and our SQL servers, because we're not serving these large blobs directly out of SQL Server every time we need them. We fetch them and they go into the file system of the web front end, so it's a tremendous offload on the network connection and on the SQL Server. Now, if we're using the max age attribute, whether we realize it or not, we can also significantly reduce requests coming into the WFEs because those same requests get served directly by the client browser. So that's blob caching. Next up, we've got page output caching. And this piggybacks on ASP.NET's output caching mechanism. So if you understand ASP.NET output caching, you probably already understand this. So in the case of our page, it's easier to simply put X's through the content and items that aren't covered by page output caching than it is to show you which ones are. And I've only got X's through images and multimedia types here. In essence, the entire HTML page gets cached in memory and served back to the user. So like I said, it's backed by memory. It's turned off by default, thankfully. I'll explain that in a second. And then there's no default size or allocation. Pages go into memory as our profiles dictate. And so since there's no default size or allocation, and it's a variable memory load, we do get a new trick with SharePoint 2010. If I go out to my web config and dive back in, you'll notice I have an output cache profiles element where I can override settings that are made within the site collection admin settings from within the web UI. So that gives admins the final say on how it operates. So how does the page output caching work? Well, at a very high level, it's like a big lookup table. Each page request that comes into the server is broken down into a set of characteristics. And those characteristics are based on page output cache profiles that you have available to you within SharePoint. And it includes characteristics like browser type, the type of page you're requesting, etc. All of these different characteristics are used to build a key. Now notice I said this is based on the request. It doesn't actually, it makes no difference what actually gets rendered into the page that the user requested. The caching mechanism is driven off the request itself and characteristics that are available within that request. Now, once the key has been built, the cache in memory is searched for a page with that key. If a page exists in memory with that key, it gets served back to the user. The page processing pipeline is bypassed. But if no match is made, for instance, if I'm requesting page XYZ using Internet Explorer and somebody else comes in and requests page XYZ but with Firefox, and I'm varying by browser type, which is pretty common, then I'd need to re-render that page and insert it into memory so that the next request that comes through can pull that page out of memory unless it gets ejected for time reasons or gets invalidated in some other way. So the trick here is to balance profile granularity against memory consumption. I can specify a huge number of characteristics to partition pages in memory by to build that cache key that I was talking about. The problem is the more granular I get, the more memory I consume when pages are being rendered. But if I go too loose, if I don't use enough characteristics when I'm building the key, then the result is people may see pages they're not supposed to see. So it's a trade-off between granularity and memory consumption. This probably sounds great, right? I get to completely bypass page processing and serve things straight out of memory, right? Well, I'm here to tell you, don't turn it on right away. You really, really, really need to do some multi-user concurrent testing with your cache profile settings. There is a story around this. I talked about granularity a few seconds ago. I was in a situation where we were getting set to enable a site for public usage, and we had a number of different users banging on the site. And all of a sudden, one user was seeing information from another user, then another user was seeing somebody else's information. The net effect was my profile was not granular enough to differentiate one user from another. So I had to go back and test my profiles and add additional characteristics to be used as part of those cache keys. Had I not done that, users would be seeing each other's data, And that's why you need to do multi-user concurrent testing, because if you don't do that, you're never going to see these situations where users are seeing one another's information. So looking right here at the farm again, page output caching, this is one of the biggest bangs for the buck because you can bypass all, or at least in most cases, all of the page rendering pipeline. Massive performance and page serving improvements. It is one of the tougher mechanisms to use and tune, but the benefits are tremendous. And finally, just quickly, we've got the Office Web Apps cache. This is SharePoint 2010 only. And in essence, what it is, it's an area for us, if you're using the Word web application or PowerPoint web application, it gives you an area to store images, XAML, and other items that are used to render those documents within the browser. The cache is implemented pretty simply. If you go into Central Administration and you have the Office Web Apps cache, you've probably seen this Office Viewing Service cache. It's a standard Teams site, and it gets provisioned through a timer job that gets installed with the Office Web Apps. Each web application gets one of these site collections, and this is where the Office Web Apps stores all of these different images in XAML that go into serving up your Word and PowerPoint docs. It can grow to consume 100 gigabytes by default, and it does have a 30-day content expiration period. Now, as you might imagine, you do have some control over this. You want to get friendly with the Set Office SP Web Apps Cache PowerShell command line. It allows you to tune some of those settings. I also recommend relocating the cache site collection to a dedicated content database. There's no reason you need to be backing up the site collection that includes just cache information, so you can save yourself some storage space. You can increase the cache size and expiration if you've got largely static documents, decrease size and expiration on the other side if you've got dynamic or highly collaborative Office docs. And don't worry, I've got some scripting support for you on these through something that I put together. So to jump straight into that, some references and resources, since I'm at the end of my presentation here. These are a bunch of different links, and I know it's going to be tough to kind of copy these down. Since it's being recorded, it may be a good idea to go back over and rewatch the recording so that you can get these. I have some additional ones again. This is all Blob Cache, Page Output Caching, Object Cache, Office Web Apps Cache, and then a few other things. And finally, my name is Sean McDonough. If you want to get a hold of me to follow up on this, I can be reached at SharePoint Interface. I'm also at seanmcdonough@idera.com. And I am the co-author of the SharePoint 2007-2010 Disaster Recovery Guide. So if you're in the DR business, I encourage you to check them out. And with that, I thank you for your time.
Okay, Sean, we do have one question. Do CAML queries and managed code utilize cached objects in object caching?
CAML queries do not specifically, there is no built-in plumbing to my knowledge that a CAML query result will go into the object cache, because I know that this commonly gets asked too with some of the web parts. Since some of the web parts that allow you to do CAML query roll-ups and things like that are present in WSSv3 and SharePoint Foundation, you know, can I use the object cache? Well, the answer is generally no, because it is a premium feature. So a CAML query alone won't allow you to do that.
Okay, great. If anyone else has any questions, just go ahead and enter them in the question window. All right. Well, thank you, Sean, for presenting today. And the recording will be up on the website early next week. And thank you all very much for joining us today, and have a great afternoon.